This is our last example on inequalities. This example will hopefully be useful because it will kind of tie everything that we've learned so far about it, and we'll have to apply the theory we've learned on this section. So the first rule that we've stated is that we may not multiply with an unknown variable, and we meant by that because that will affect what that sign will be. For instance, if we take a value of x equals 0, this whole term becomes positive. However, if we take a value maybe such as x equals 5, this term turns negative. So it just shows that we may not multiply by this because it will change what that inequality sign will be. So the second thing we need to do is we need to determine the factors or the x values for which each of the brackets equals 0, and then we draw a table. So a table is nicely drawn here. We have 2x plus 1, we have 2x plus 1, we have x minus 1, we have 3 minus x, and then the next thing we do is we draw the this number line. But how we get to this number line is we first take that first term here, 2x plus 1, which is that, right? So we take that 2x plus 1, we equate that with 0, we solve for x equals minus a half, right? And we solve here again for this one. We say x minus 1, we equate it to 0, we solve x equals 1. And now for the last one with 3 minus x, we have 3 minus x, we equate it to 0 and solve for x equals to 3. Notice that what we basically did, we took each of these brackets and we equated to 0 and solve for those values. So we have these values here. X equals minus a half, x equals 1, x equals 3, right? And then we go put those on the number line. So minus a half, 1, and 3, right? So we have those. So the next thing to do would be to determine the impact, the sign impact of these if we have values on each of these regions. So to start off, we'll take any value less than minus a half. Let's say, for instance sake, here we take x equals minus 1, right? Minus 1 lies here. So if we take minus 1 and go plug it in there, we'll have 2 minus 1 plus 1. Right, so we'll have minus 1. So in other words, this will be negative, right? And then if we take minus 1 again here, this is it will be negative because we'll have minus 1, which is negative. If we put, however, minus 1 here, it's going to be 3 minus 1, which is 4, which is a positive value. So this turns out positive. And then now let's take 4 values between, these are 4 values less than that. So now let's take 4 values between minus a half and 1. Such a value could be minus a quarter. So if we take x equals minus 1 over 4, we will have 2 minus 1 over 4 plus 1, we will have a positive value here, right? And then if we take the same thing here, we put minus a quarter minus 1, we get a negative value. So this will be negative. And then we take the same minus a quarter, 3 minus a quarter, which is a positive value, right? So we've seen what happens between minus 1 and 1. Let's see what happens between 1 and 3. Let's take a random value, maybe 2, right? So if we plug in 2 times 2 plus 1, we get 5, which is a positive value, right? Here, if we plug in 2 minus 1, for instance, we get what? 1, which is a positive value. And then here, if we plug in, for instance, 3 minus 2, we get 1, which is a positive value. So that's what happens here. Now let's see what happens at values greater than 3. Let's take 4, for instance, right? So if you try to do the same thing, you'll learn that if you plug in 4 for each of these values, you'll get positive values. You'll get positive for this one, and here you'll get positive as well, and then for the last one it will be negative. Same procedure. And then now let's get to the how we use this, right? So for the first case, for this region, let's write down for this region, right? We're looking at, I want you to note, so we have this term and that term, which is the top term. So if we multiply negative and negative, which is this value, we'll get a positive value. And we divide, right, by a positive value, it's still a positive value. So in other words, for values less than minus a half, we get a positive value. Let's see what happens here. We have for 2x plus 1, we have a positive value. For x minus 1, we have a negative value. And for 3 minus 1, we have a positive value. So a positive times a negative is a negative, and a negative divided by a positive is a negative. So between these values, between minus 1 and half, it's going to be a negative value. So here again, we multiply a positive value and a positive value, we get a positive value, and we divide by a positive value, we get a positive value. However, here we have a positive value times a positive value, which is positive, but when you multiply by, we divide by a negative, it's going to be negative. But now coming back to what the question's asking, the question is asking for which values will this thing be positive, greater than 0. So we see it's going to be positive in this region because it's positive, and also in this region, right? So to write that a bit neat, we say x needs to be less than equals to minus a half, right? Or, so because x needs to be any value, we took any value less than this, so that's why that's true. And then here we took value between 1 and 3. So, and also we need to have 1 less than x and then 3. So in other words, any value between 1 and 3, this will hold true. So do you notice what the inequality sign basically, it's basically a comparison sign. So we're trying to find which values for will this be positive. So do you see how useful the table is when you first find out what the factors are, the x value that gives 0, and then write them down and try to find out what happens on each of these regions, right? And you notice that we've written down these, right? These values that give 0, and notice that the sign changes in each of these values, So what we indicated previously was true.